Guys. So today we will be dealing with the fourth chapter of NCRT, that is motion in a plane. I'm sorry guys, I don't know why the dog is barking like anything. I don't think that will be causing that much disturbance in the video. Extremely sorry guys, can't do anything about it, don't know what happened to it. Okay, so we are going to deal with the chapter motion in a plane. Now there is another name for the same chapter, just like the previous chapter. It is also called motion in a or in two dimension. Earlier chapter was called motion in one dimension, right? Similarly, this chapter is called motion in two dimension. Clear? Now, why this two dimension chapter is going to be taken is actually relatively all the things which you see in your world or life is actually multi-dimension, right? But the science has actually dealt with, or the your guys, I can say you guys are still learning till two dimension only, but you would have seen 3D films also, right? So there are three dimension. Similarly, actually scientists say there are six dimensions which you can actually learn, but till now basically students are taught till 3D only, right? But actually you guys can study till 6D also, but as you get older you will know about it. Okay, so let's move on. So what is two-dimensional motion? What do you mean by that? Actually, we actually dealt with two dimension in the previous chapter itself. See, I have a ball, right, and we threw it, right, and we threw the ball and this ball came up and it reached the ground. So what and all parameters we try to find? We found how much velocity will be there when it reaches the maximum height. Similarly, how much time it takes for coming back to ground. Similarly, we found what is the maximum height achieved, right? That I told us now. So these and all are the parameters we found. But actually, see, if this ball, if you talk about y displacement, of course, in y direction, see, this is 2 meter, right? This is the initial point. So in y direction, obviously this position is again 0 in y direction if you plot it graphically like this, right? So this is y, this is x. So this point, if I take it as 0, then this point is also 0, right? But see, this is 0 0. Why? This is for x parameter, right? Let's say this is having x1, this is 0, right? So this point which is here, which is I am darking like this, can be written as 0 0, right? So actually this point, right, which I am darkening it now, is actually said to be what? X1 0. That is, in y direction the displacement is 0, but in x direction there is x displacement. This much displacement is there, right, which we are not mentioning in the previous chapter. So in this chapter we are going to deal, when this ball is thrown, there are two direction displacement, one in y direction and the other in x direction. So how and all we are going to deal is something which you are going to learn in this chapter. Clear? So as you can understand, in this chapter we are going to give much importance to direction. So just because we are going to deal with direction, we have to deal about what is known as vectors in detail. You have learned about vectors in little bit in your 9th class, right? So actually this is a continuation from the 9th class itself. So you know, any physical quantity is written as nu, where n is a numerical quantity and u is the unit. Say if you are asked to bring 5 kilogram of what? Mango, right? You're purchasing 5 kilogram mango, means 5 is n and u is kilogram. Kilogram is a unit and n is the numerical value, right? This is how you represent any physical quantity. You are representing mango's weight. So weight is a physical quantity and this is how it is represented. It is given as a product of numerical value and unit. This is something which you have learned in the first chapter. Yeah. Now suppose you have a friend, or suppose he is an enemy or whatsoever, right? He is dying, right? In the last moment, this is you, okay? In the last moment he told, this is the enemy, let's say, or friend, whosoever, and this is you, right? He told you on when he was taking his last breath, he told you that I have hidden a treasure, or my treasures are being hidden in my plot itself, and it is around 5 kilometers away from the well, right? So he just told you this and he died, right? So you were very happy. You went to his home, right? And you found the well. Say this is the well, right? And you know only that some treasures has been hidden by that person 5 kilometer away from the well. So this 5 kilometer can be in this direction, can be in this direction, here in multiple direction, right? Or I can say this 5 kilometer can even be inside the earth, right? It can be deep, 5 kilometer deep, right? So the person failed to give you what? He failed to give you direction. If you had known the direction, it was easy to find where the treasure is without that much difficulty, right? Similarly, same, you are you ordered some Amazon, you ordered some, order something from Amazon, and the delivery man called you, and you're just telling, and he told that he has reached the meeting point, right? But he doesn't know where your home is, right? So he called you and you're just telling, oh, you just turn for you just move to around 6 kilometer away from the point you are standing. You're not telling you if you have to move forward, backward, left or right. You're not giving proper direction. So can you receive that Amazon or the thing which you ordered in the Amazon? No. Or the delivery man will be finding it very difficult to give you that material, right? So all the quantities which you just told that can be represented by the combination, right, as n into u. Just knowing the now numerical value and unit is not enough to describe physical quantities. There are some physical quantities where along with the numerical value and the unit you require direction, right? And those type of quantities are known as vectors. Clear? Right. So physical quantities, all the physical quantities, basically we can actually divide into two, that is scalars and vectors. Right. Now what are scalar and vectors? Differentiation. How can you differentiate? One, or I can say major difference you have learned in your 9th class is scalar has, you can say, has only magnitude. Okay, why is not my pen writing magnitude, right? Whereas vector is something which has both magnitude and it has direction, right? This you have learned in your what, basically I will say around 9th class, or I think you have told about this in the first chapter itself. So but there is a very important point, right? Here all the scalar, see, you have 2 kilogram mango, you ate that 2 kilogram first, then you ate another 2 kilogram of mango, and somebody asks you how much kilogram you ate, means you straight away say I ate 5 kilogram, right? So that means, and weight is a, or mass is a scalar quantity also. That is, it doesn't require, you don't require to say the direction of mass, right? So those type of quantities are known as scalar. That means in adding two scalar quantities, this is scalar, this is scalar, you are undergoing what type of operation? Normal arithmetic operation, right? So in adding two scalar quantities you require what type of method? Arithmetic operation, which you have learned. But if you are talking about vectors, vectors always require or has to follow vector law of addition. It is very, very important, and that is something which has to be followed by the vectors. Clear? That is, it has to, or it has to always follow what? Vector law of addition. Now I will tell you what is the importance. See, okay, there is a boy called Bala. He is moving around 3 kilometers in this direction, right? And he reached here, right? And let's say again he walked 4 kilometers, right, in this direction, right? That is in each direction. I hope you know this is each direction. Well, because before going there, you hope you know the directions. This is north, south, east and west. This is northeast, southeast, southwest, northwest. Suppose a person is telling that he was traveling in east direction and suddenly he moved in northeast direction, means this is the direction, right? 45-degree north to east means this is how you are supposed to draw. Okay, I'm just giving you an idea. This is something basic things you have to know. Okay, so B is traveled 3 kilometer, then he traveled 4 kilometer, or Bala, right? I told you about Bala. So that means how much is the displacement? Easy, right? That is 7 kilometers. Clear? Now same Bala, first 3 kilometers, right? And he comes back 4 kilometers. So I'm not going to take the direction. If you normally if you had not known about displacement at all, you would have written, okay, Bala again has traveled 7 kilometers. Now same, Bala 3 kilometer like this, then 4 kilometer like this, and you are asked what is the displacement, right? This is Bala's initial, this is final position. Again, you will just, if you had not known about direction, you would have given the displacement again as 7 kilometers, right? But you actually know in the second case, if Bala is coming back, so actually you are supposed to take 3, if we are taking this direction as positive, plus minus 4. This direction becomes negative and becomes displacement is minus 1. And here displacement is final and initial position distance. So this is final, this is initial, so this is 5. So again the displacement is not actually equal to 7 kilometers, it is 5 kilometers, right? So this is something you know. So that means here displacement is not, right? To find the value of displacement, you have not added it arithmetically. You have given importance to a direction, or you have used a different method, right? That is known as vector addition, which you have to deal later on. I'm just giving first an introduction part, guys, right? So I can say in the first case here, what was the angle between this position and this position? Between 3 and 4 kilometers, the angle is 0 degree. In the second case, what is the angle between 3 and 4 kilometers? It is 180 degree, right? This is in this direction, this is in this direction, right? Whereas in the third case, what is the angle between two displacement for 3 and 4? It is 90 degree. So I can say the displacement changed, right? Initially the displacement in 7, then it became minus 1, then it became 5 kilometer here, right? So displacement changed according to the angle between what? 3 kilometer and 4 kilometer, right? Or I can say the direction has changed, right? So as the direction has changed, the value of displacement has changed. Clear? Right? So there is a method by which the actual positions, if you want to find displacement, the positions or the displacements 3 and 4 which you have written earlier has to be added in a different method which you will learn later on. Clear? Now before that, so that you understand those materials, or there are some quantities where both magnitude and directions are very important, right? And those terms are called, or quantities are known as vectors, right? Now how do you represent a vector? See, if you write a vector and you are asked, okay, A is a vector quantity, it's a physical quantity, or I can say, let's say force is a physical quantity, right? It is, force is supposed to be written, suppose you are told that I applied a force on a material in this direction, so this is south, right? So I applied around 5 Newton, right? It is not writing 5 Newton in south direction. Then how would you write in sentence 5 Newton in south direction, right? This is how you will write. Now the force is supposed to be represented like this. Force is a vector quantity, so vector quantity is represented by writing the alphabet for that quantity, and above that an arrow is drawn in this direction. This is how you are supposed to write a vector. Suppose similarly, velocity is a vector quantity. How you are supposed to write? V, and above that there should be a arrow. Similarly, displacement, vector quantity, draw an arrow, right? Acceleration, vector quantity, write A, above that an arrow. So how is vector represented? A, above that an arrow. So how would I write? A, this arrow is equal to 1 meter per second square. Clear? Alright. Now similarly, some of the sections you would see the acceleration itself, it is written in this form, right? 2 bars will be written and here A will be written. This represents magnitude of acceleration. See, when you are writing a vector 1 meter square north, right? So same A I am writing in magnitude only. So I require only magnitude. So A vector I will write in the magnitude form like this with 2 bars, and I will just write 1 meter per second square, right? Because this just representing magnitude. So what is the magnitude? It's just 1 meter per second square. North is the direction. So when you write a bar, you are supposed to write only the numerical value. See, I will tell you. Suppose force, right, is 6 Newton west. So you are asked what is the magnitude of force. You are supposed to write it like this, and you will just write it like this. Modulus F is equal to 6 Newton. This is how you are supposed to write the magnitude. This is the symbol like that. Clear? So vector is also can be drawn, right? So how is vector drawn? Right, so you draw, right? It's like a line, right, where the length of the arrow gives the magnitude, right? This is the tail, this is tail, and this is head. I don't know why it is not writing. Sorry, this is tail, this is head. Clear? Suppose someone asks you to write 3 Newton east. East. How to draw it? You will draw it like this. Which is the east direction? Remember, this is north, south, right? This is east and this is west, right? So 3 Newton is supposed to be written like this, right? Clear? So you can either write, some of the books will write 3 Newton here, or you can write 3 Newton here, because this length of the arrow represents the magnitude, right? So actual way of writing is how? If again I will give you another question. Suppose you are given a momentum, right? 6 kilogram meter per second, right? This is the momentum is given, right? So 6 I will write it as what, and the direction is given north. So how do you draw 6 like this, and or in place of 6 actually I am supposed to write here, right? Magnitude is written here and the direction is given by the arrow. This is head, this is tail. Clear? Now how can I say two vectors are equal? Two vectors are said to be equal. Let us say, suppose I am taking displacement 6 meter east, 6 meter west, right? So 6 meter they are having this, both are indicating what? Displacement. That means it is a vector quantity. Let's say this is S1, this is S2. Now S1 and S2 are having same magnitude, that is 6 meter, but their direction, one is east and one is west, so they are not in same direction, means S1 is not equal to S2. Clear? Right? But I can say, see, 6 meter, if I draw in a vector form, see 6 meter east this direction, 6 meter west in this direction. So I can say they are both in opposite direction of same magnitude, right? So actually S1 is equal to minus S2, right? That means these two vectors are opposite vectors. They are not equal. Clear? Or I can say, right, so minus I2, you understood? That means if we learned a lot. So if you have two vectors where you are writing a, right, a vector, you're drawing like this, right? So if you are asked to draw a minus a vector, you have to exactly draw of the same length vector but in opposite direction. This is minus a vector, this is a vector. Clear? Keep that in mind, guys, right? So now we are going to know about what you known as unit vectors, right? Unit vectors are those vectors which has magnitude 1 vectors, that is which having this and all we will take it later in details. I'm just giving an idea. Unit vectors, a type of vectors which has only magnitude 1 and it is represented by a cap, so that if the vector a is there, so a cap is written by or mentioning the unit vector of a. Okay, I will tell you in another form. I hope you understood what you just understand with the names, guys. I will tell you about in detail later on. Okay, you have to calculate. You have a lot of numerical section. Now, when do you say two vectors are collinear? Right, collinear. See, this is one vector A. If I have another vector B and they are in the same line, then I say they are collinear vectors. Right? Or I can say, what is the angle between these two vectors? 0 degree, right? Or I can say, see, if this vector is, I'm just telling you the terms, right? If there is another vector b like this, right, they are of not the same magnitude, but I can say they are in the same direction, hence they are known as parallel vectors. They are not collinear, guys. Even if the angle is 0 degree, they are not collinear, but they are known as what? Parallel vectors. So if someone asks you whose anti-parallel vectors, how would you draw? This is a vector and this is b vector. Those are what? Anti-parallel. Clear? And what is the angle between them? 180 degree. When do you say two vectors are perpendicular? Like this, a vector, b vector, this is 90 degree. Clear? Now, when do you say two vectors are concurrent or two or more vectors are concurrent? So this is my this is vector A, this is vector B, this is vector C, A, B, C, right? They are concurrent means they are meeting at one point, or I can say I feel that they are originating from one point. See, these need not meet one, looking at one point, I can say sometimes they may not appear meeting from one point. But if I extend it like this, so it feels like it is meeting at one point. So these three vectors are concurrent. Clear? Now we will be dealing with the next today in this video we'll be taking only a small portion, guys, because it's a little bit vast topic, but I will just give you a small introduction part, or I will if the time is available, I will do at least I will start that portion. Okay, so the topic which we are going to deal now is called addition of vectors, right? So why I'm going to take, or why this section, that is addition, is something which you have learned, I would say, from your lower classes, right? So it's not a big deal, but still I'm telling you as a specific topic in this chapter, so there should be some difference, right? So normal, or I can say normal operation of addition, what would you do? It's an arithmetic operation, you will just add, you know how to do it, right? But when the vectors are added, what is the property of vector? It has both magnitude and direction. So if you had been asked adding, suppose, two distances, 2 meter and 3 meter, what you would do? You would add 2 and 3, right? Because in distance, since being a scalar quantity, there is no significance of direction. But if you are asked displacement, right, so you have to know in which direction the 2 meter is and in which direction the 3 meter is, right? So here, when vectors are considered, direction is very important. So why we are doing addition of vectors? See, if there is a body like this, right, and I am applying 5 Newton in this direction, and I am applying, say, 15 Newton in this direction, right? See, if it had been 15 Newton in this direction, I could have said easily that 15 plus 5, that is 20 Newton is acting on this body. But see, as I have drawn earlier, see, the 5 and 15 Newton is in perpendicular nature, right? So it's very difficult to say
what is the resultant force which will be acting on that body, right? Because direction is different, it's not in the same direction or neither it is in the opposite direction, it's perpendicular, there is an angle between the two forces, right? So addition of vectors, we take it as a separate section whenever there is action of multiple vectors, more than one vectors, forces or vector quantities are acting on any object. Usually in the next sections you will deal with the force, that's why I just told multiple forces, right? So when you deal with addition of vectors, it only appears when on one body, right, on one or multiple bodies there is a multiple amount of vector quantities are acting, then that period we have to use the concept of addition of vectors. Now actually addition of vectors, right, actually there are two different way we can do the addition. One is triangular method and the other is parallelogram method. Triangular method is there, parallelogram method is there, and graphically we will deal with this, right? First we will find graphical way. Why I am going to deal with graphical way? First I am going to tell you, if you are given two vectors, right, then how can I find their sum, right? Their sums direction, right? Then suppose there is two vectors, say A and B, and so that if they are added you will get a magnitude of C, that you know. But you don't know, since these two vectors A and B are in vector forms, so C will be also in vector form, right? So what will be the direction of C, right? That will be taken now, guys. Clear? Now how we will do? First we'll use the method called triangular method. That is, by using triangular method I'm going to find the direction of the resultant of sum of two vectors. That is, if A plus B is C and I know the direction of A vector, I know the direction of B vector, then what might be the direction of C? So first, how will we deal with the triangular method? It's very easy, guys. Let's say you are given, see, we are not finding the magnitude, guys, we are finding the direction. I'm having A vector in this direction and let's say B vector is in this direction, right? So and I am asked what will be A plus B is equal to C, this C vector's direction. I'm given A vector's direction, I'm given B vector's direction, and I'm asked what will be the C vector's direction. So triangular method is also called head to tail method. Now why it is said, I will just tell you now. Okay, what should we do to do a triangle method? We have to make a triangle. How? So if A plus B is asked, keep A as it is. As mentioned, drag the B in such a way that head of A, right, and tail of B, this is tail of B, right, meet with it. That's why the head to tail method. Head of A is meeting tail of B, right, and meet the initial point of A and final point of B, like this, right? So that from initial to final, draw the arrow. See, or if you're having a difficult, I will say an easier method. See, if it had been a direction like this goes like this, then it is continued like this, right? So actually, if you had drawn normally, what would you do? You will draw like this, right? The arrow should go in this direction as per you. Just draw opposite to it. Opposite to this direction is this one. I drew like that, right? Clear? So C's direction will be in this, that is in this direction. Clear? C vector will be in this direction.